Hello, welcome back. To get your mind wrapped around what we're going to be doing in this video, I want you to pause the video and try these first 4 questions as a do now. Now that you've paused the video and you've come back, let's take a look. As we classified each of these, we know that our first answer, if we have 90 degrees, we have a right angle. 72 degrees is acute. 180 degrees is a straight angle, and 116 degrees is obtuse. So these are different angles that we've seen before, which will help us with what we're doing now. So to start, we're going to look at triangle angle sum. So in our previous video, we talked about adding up the sum of the angles in a triangle equal or sum to 180 degrees. And we also looked at exterior angle theorem. But today we're going to look at so that students will be able to classify triangles and use those classifications to answer questions about triangles in order to gain a deeper understanding of shapes, specifically triangles. So this title at the top here would be appropriate to write at the top of your notes, triangle angle sum. And specifically we'll look at classifying and then different classifications of triangles, but those will be subheadings underneath this larger heading. So classifying triangles by size. We have 3 different ways to classify. Many of you have probably seen these before. We have scalene, isosceles, and equilateral. Now these 3 ways to classify, we're going to draw 3 different looking triangles. And a scalene triangle is where no 3 sides are congruent. So to show that, I'm going to put different little dash marks or different amounts of dash marks on each side to show that those are not, that none of them are congruent with each other. An isosceles triangle has 2 congruent sides, and an equilateral triangle, we see equa, which is like equal, and then lateral, like lines or sides. So we have all congruent sides. So here's how it would read in English. Scalene has no congruent sides. Isosceles has at least 2 sides that are congruent. Equilateral has 3 congruent sides. And these are how we classify triangles by their size. Now, triangles don't just have sides, they also have angles. So to classify a triangle by its angles, we have a couple of ways to do that also. And we've looked at angles before. So to look at the angles, we have acute, we have right, we have obtuse, and we have equiangular. So acute, we have 3 acute angles. So they don't necessarily have to be congruent, but notice how we have an acute angle, and another acute angle here, and we have another one here. They're not necessarily congruent. We have a right triangle, which has 1 right angle, and we label that with that little square in the corner, or square off the corner there. We have an obtuse triangle has 1 obtuse angle, and an equiangular, we have 3 congruent angles. So here, we're going to illustrate that these angles are all congruent by putting the same little arcs, the same number of arcs. So if I have, on the picture I have here, I have 1 arc for each of the angles, or I could have 2 arcs for each of the angles, and that would show that they are congruent. So classifying by size, classifying by angle. So let's try, you try. So pause the video and classify each of these by their sides and by their angles. Now that we've come back, let's take a look. So this first one here, we notice that we've got a really short side, we've got a longer side, and then this is the longest side. So we have, classifying it by its size, we have a scalene, and then we have an angle that's greater than 180, so it's scalene and obtuse. This one, you have little marks right here, number 2, and those are congruent to one another. So we have an isosceles And then no angle is greater than 90 degrees, so we have an acute. And then here, we also notice that the three side lengths are three different sizes. So we have a scalene and we have a right. So each triangle can have has two different classifications that we need for them. So let's look at isosceles triangles specifically. So here is a picture of an isosceles triangle. I'll give you a moment to draw this, and while you're drawing this, take a look at the different vocab words. So we have our two congruent sides, and those are called our legs. Then the side that's not congruent is called the base. So at the base we have what's known as the base angles. We're going to talk about what the base angles are, but they're the ones down here. And what do you notice about them? They appear to be congruent, and we'll look at more details to come. And then we have that vertex angle at the top. So for example, this vertex angle is 20 degrees, and notice how the vertex angle is between the two legs, the two congruent legs. So you could also draw a isosceles triangle that might look like this. And since I'm not the perfect artist, I can put little marks to show that it's an isosceles triangle. And my base angles here would be these ones at the top. So even though they're called base angles, they might be on the top or on the side, but they are always opposite of where the congruent sides are. So opposite, we're looking at the angle that's opposite the side. So we're going across there to check out that angle. So looking at isosceles triangles, we have a couple different ideas of them. So here's one idea that that we can see is true. It says if two sides of a triangle are congruent, then the angles opposite them are congruent. And that's kind of what we saw up above. So if we know that those two sides are congruent, and let's write this in math language. So if AB is segment AB is congruent to segment AC, then the angles opposite them are congruent. So opposite of this side would be angle C. Then angle C would be congruent to angle B. So we started with AB. AB corresponds with or is associated with the angle opposite of it, which is angle C. So we can say that these angles are congruent, and how we show that is with those little arcs. So we could have arcs on those base angles. Then we could also say the same the other way. So if two angles of a triangle are congruent, then the sides opposite them are congruent. So if I say angle B and angle C are congruent, so if, and you could add an if in front of here too, if angle B is congruent to angle C, then the sides opposite them are congruent. So the side opposite of B is segment AC, and the side opposite of C is segment AB. So if we know that the angles are congruent, then the sides opposite must also be congruent. So then if we get a picture and it looks like this, and the angles are congruent, then we can put those marks there. So because this goes in both directions, then we can actually say this term, or this sentence. So therefore, two angles of a triangle are congruent if and only if the sides opposite them are congruent. So if and only if is a mathematical phrase that we use, and it's kind of like an equal sign, but even more telling that you can go either direction with this information. So how we write this is we can say angle B is congruent to angle C, and then we might use ISS for if and only if. Segment AC is congruent to segment AB. So that means that if we start with our segments, then we can go to our angles, or if we start with our angles, we can go to our segments. So using this in actual application, let's try a question or two. So example 1, find the unknown angle measurement. So in part A here, we have this image and we're looking for the measure of angle X and the measure of angle Z. This is a Z here. So if this is 50 degrees, then we know that these and these sides are congruent. We have an isosceles triangle. And we know that these angles down here must be congruent to one another. So because of that, we know, and we also know that all the angles in a triangle sum to 180. So what we're doing essentially is saying the measure of angle X plus the measure of angle Z plus 50 degrees equals 180 degrees. Well, let's subtract the 50. So we have the measure of angle X plus the measure of angle Z equals 130. And then we know that the measure of angle X plus the measure of angle Z, we know that those measurements are congruent, so therefore we can say that they are equal. So really, I could replace this. I know that the measure of angle X equals the measure of angle Z. So I can replace one of these with the other. So I could also say the measure of angle X plus the measure of angle X equals 130. So then I would have two measures of angle X equals 130. And then we'll divide by 2. So we get the measure of angle X equals 65 degrees. And because that's congruent and that's equal to the measure of angle Z, then that would also be 65 degrees. Now, a lot of this we'll end up doing in our head over time, but this is the full process for it. So let's look at the next one. We see that the measure of angle A is 12, and it's only asking for the measure of angle B. However, with these symbols here, we know that C is congruent to A. So we can just do measure of angle A plus measure of angle B plus measure of angle C equals 180, like we learned previously. Measure of angle A is 12 degrees, plus the measure of angle B, and the measure of angle C, because these are congruent, is also 12, equals 180. And now we can combine like terms, so we get the measure of angle B plus 24 equals 180. And then we will subtract that, and you'll get the measure of angle B. So noticing that our angles here, we'll always write them in degrees also. We subtract this measure of angle B, then will equal 156 degrees. So don't forget to put the degree symbol on there. Now, did you have to show all of these steps to get here? No, as long as you show your work in order to get there, that will be sufficient. However, this is laid out the whole process because we're looking at just the definition of triangle angle sum, that theorem we talked about yesterday, and then substituting in order to solve. So in Algebra 1, you probably minus 24 wrote that on both sides. But now that we're in geometry, we can move forward with that. So we got both of those answers. Now let's take a look at another kind of triangle, equilateral triangles. So equilateral triangles we've already discussed a little bit, and so we know that they all have three congruent sides. So if we have three congruent sides, then all of these angles actually must also be congruent, because the angles and the sides opposite have a relationship together. So the measure of each of these angles, if they all have to be the same, then we're going to look at 180 divided by 3. So each of the angles is 60 degrees. Now here are a couple questions that we're going to go through quickly. So the first one here, if we're going to look for the unknown measurements, if we know that this side is 5, then we can say that the other two sides are also 5. If we know that this angle is 60 degrees, then we know that the other two angles are also going to be 60 degrees. So the measuring angle Y is 60 degrees, measuring angle Z is 60 degrees, Y, Z, the length of Y, segment Y, Z is 5, and the length of segment XY is also 5. So using both of those skills, from understanding those triangles, isosceles and equilateral, we can look at this question. So find the value of x and y in the diagram. If we have all congruent angles here, then we also know that this is going to be equilateral. So therefore, if KL is 4, then y must also be 4. And if we have base angles congruent on this triangle here, then we know that this side and this side must also be congruent. So if y is 4 and NL is 4, then we can say 4 equals x plus 1 to solve for x. So we'll subtract 1, we get x equals 3. So we're using the knowledge from equilateral triangles and the isosceles triangles to help us solve different questions.